Today we're going to be talking about scaling one dimensions. Now we've looked at cones and cylinders, and now we're going to actually look at what they look like graphed and situations dealing with those two volumes. So let's get started. So driving the distance. Here's a graph of the amount of gas burned in a trip using a tractor trailer that drives at a constant speed down the highway. So it says at the end of the trip, how far did the truck drive and how much gas did it use? Well, let's see. If I look at my graph here, I know that it stops right here. So if I go down, I can see that it's 240, and if I go all the way over, it's 30. So they traveled 240 miles and used 30 gallons of gas. Okay. It says if the truck traveled half of the distance at the same rate, how much gas would it use? Well, let's see. If I cut this in half, 240 divided by 2 would give me 120. So I need to look at 120. And I can't really tell. It's between 10 and 20. But what I do know is that I cut 240 in half. So now let's take 30 and cut it in half. Well, 30 and half of 30 is 15. So it used 15 gallons. So I know that this point is 120.15. You don't have to write this, but so it will travel 120 miles and use 15 gallons of gas. Okay. Now it says if a truck traveled double the distance at the same rate, how much gas would it use? So now I'm actually going to double it. So what I'm going to do here is I'm going to take my original 240 and 30 and double it. So 240 times 2 is 480 miles. And the gas, 30 times 2, is 60 gallons. So it will travel 480 miles and use 60 gallons of gas. That's a lot of gas and a lot of miles. It's almost all the way to California. Depending on what part, of course. So now let's look at cones and volumes of them, because that was kind of a review from our functions part of our unit. So here's a graph of the relationship between the height and the volume of some cones that have the same radius. What do the coordinates of the labeled point represent? So I'm going to look at this labeled point here. I'm going to see what it represents. Well, the 10 is the height, and the 2,355 is the volume. So I'm going to say a cone with a height of 10, and let's just do inches. Let's keep it consistent. 10 inches has a volume of 2,355 inches cubed. Holy cow, that's huge. Alright, so it says, what is the volume of the cone with a height of 5? What about 30? Well, I'm going to separate these. I'm going to do a height of 5 here and a height of 30 over here. So I know that this height is 10, and half of 10 is 5, that means I can actually take the volume of my 10 height cone, the 2,355, and actually cut it in half too. Because if I cut the height, if I cut the height from 10, that's going to give me my height of 5. Now if I take the volume from our 10, 2,355 and cut it in half, then I can find the height, the volume of my height of cone, that of 5. So 2,355, of course you can always use a calculator to figure this out. Oops, I don't have enough room. There we go. So if you plugged it into a calculator, you might have gotten something like this. Yep, perfect. So the volume of a cone with a height of 5 is 1,177.5 inches cubed. Crazy. Alright, so if the height of a cone with 30 now, I'm going to increase. I can't see it. But what I know to get my height from 10 to 30 is multiply it by 3. So if I take my original height that I've dealt with, multiply it by 3, I'll get that 30-inch height. Now that means I can do the exact same thing with that volume of 2,355. If I multiply it by 3, I get 7,065 inches cubed. And that's how you use your reasoning skills, because if we know one point, we can most likely find the other points, either by cutting it in half, multiplying it by 2, 3, whatever. So there's a few more questions on this cone dilemma. So let's see what our other cone is. Our other questions are. It says use the labeled points to find the radius of these cones using 3.14 as an approximation. Well, I know the volume of a cone is V equals 1/3 pi r squared times my height. So I know my height is 10 and my volume is 2,355. So I'm going to zoom in here so you can see. So now what we're going to do is we're going to try to find what the radius is. That's what it's asking for. So I'm going to plug in what I do know and leave everything else blank. I know my height is 10. I don't know what my radius is. I know what pi is, but I'm going to leave it alone for right now. And my volume is 2,355. Alright, so let's see. I can actually combine my 1/3 and my 10 together. That would give me not a nice number, so I'm going to leave it as 10/3. I'm going to change pi now to 3.14. I'm going to multiply it. I'm going to put my radius to the back of my equation, because I'm not dealing with it until last. And of course, bring down your 2,355. So let me pull up my calculator. Alright, so I'm going to take 10 divided by 3 and see how I got a really nasty 33333 number. I'm going to multiply that by 3.14. And now I get 10.46 repeating. So I'm going to actually write it as 10.46 with a line over the 6, because the 6's are repeating. If I bring everything else down, now remember, these are right next to each other. They're multiplied together. in order to get r by itself, I actually have to divide 10.46666 repeating from both sides. If I do that, I'm actually going to copy this. Okay, I'm going to take my 2,355 divided by insert number. I'm going to get 224,999. I'm actually going to round this one up. So I got 249.99 repeating. I'm actually going to round this up because I want a nice clean number when I square root. So this is actually going to be turned into 250. Or honestly, you can just take the square root of it and you would get 15. So if I took the square root, because remember, if there's a number like this r to the power of 2, you're going to square root it, meaning I'm going to break them up, get rid of this 2. You actually get 15 as our radius. Okay, so now it says the last step is to write an equation that relates to the volume and height. So again, I'm going to write V equals 1/3 pi r squared times my height. Now this time, if I wanted somebody to be able to find the height of any cone and have minimal efforts of doing anything, what I'm going to do is plug in my radius, because this is why. It says all of the radiuses, all these cones all have the same radius. So all of these cones, doesn't matter the height, has a radius of 15. That is forever and forever. So my radius I'm going to plug in, which is 15. Everything else I'm going to leave alone. Just bring it straight down. Well, 15 times 15 I know is 225. I'm actually going to combine it with my 1/3. Move my pi to the butt and my h down 2. So 225 divided by 3 gives me 75. Well, that's a nice number. So you can leave it like this, 75 pi h, or if you wanted to be a super nice person and all they needed to do was figure out what the height is or plug in any number, you can take that 75 and multiply it by 3.14 to get 235.5. Times your height. Depends on how nice you want to be. Oops. It's completely up to you. You can leave it like this, or you can leave it like that, or you can put both. But that is today's lesson. So you do have a checkpoint, so make sure you log in and do your checkpoint.